Hi, welcome to my channel, JaberTime. Today I'm going to talk about the slope of a line, parallel lines, perpendicular lines, difference in y over difference in x, or rise over run. The slope of a line is defined to be the ratio of the rise over the run, which is the difference in y, y2 minus y1 over x2 minus x1. Rise over run. Rise is usually the y change and run is the x change. I have different examples and enough graphs. Hopefully that will be at the end of the video clear what is the line as an equation and what I mentioned on the first slide. The slope of a horizontal line is y equals b, a constant, is 0. The slope of a vertical line, which is equal to x equals a, also a constant, will be undefined. Here is a horizontal line and here is a vertical line. The horizontal line, for example, y equals 5, because you're going up to 5 and you're staying right there. Every point on this line could be represented by the value y equals 5. X changes, but y is fixed. Of course, if you go up to 6, you're not going to be on the line anymore. So y has to be fixed, which is 5, and the slope is 0. This vertical line has an equation of x equals 2, and x does not change. The slope will be undefined. In a different way, you could pick 2 points on this horizontal line. We'll call this one x1, y1, 1, 5. We'll call this one 4, 5, x2, y2. We'll just do the math. y2 minus y1 will be 5 minus 5, which is 0, over x2 minus x1, which is 4 minus 1, and that's 3. But 0 over any number is 0, which also supports the concept that the slope of a horizontal line is 0. For a vertical line, let's take 2 points, 1, 2, and 1, 5. This will be called x1, y1. This will be called x2, y2. We'll just do the math. y2 minus y1 will be 5 minus 2. x2 minus x1 will be 1 minus 1. And that simplifies to 3 over 0, which is undefined because we cannot divide by 0. So the slope of a vertical line is undefined. For a horizontal line, you're moving, as another example, 1, 2, 3 for the run, and there is no change in y, so there is no rise, or the rise is 0. 0 over 3 is 0. For a vertical line, you're going up 2, but you're not going right or left, so the run is 0. 2 over 0 is undefined. 2 over 0, rise is 2, run is 0, undefined. 3 over 0, undefined. That's like more examples. Now, if we have a different slope, an angle that this line is forming with the positive x-axis, the way to do the slope, we go rise over run. I could go 1, 2, that's my rise. 1, 2, 3, 4, that's my run. 2 over 4 simplifies to 1/2. Or, looking at the green color, I could only go 1 up, 2 right, and that will be 1 over 2, still the same answer, 1/2. So it doesn't matter how far you go up, how far you go right. If you pick these 2 points or these 2 points, it simplifies to the same ratio. The rise compared to the run is the same thing anywhere you go on the line. So the line has the same slope everywhere. So you pick 2 points that you could read from the grid if you are given a graph, and you go from there. What happens if it's a different point like up here or here. Well, that's going to give you different slope, and that's the idea of the slope. How fast the graph is moving up, how steep is the graph. So I have red, green, and black. We're going to apply rise over run, which is y2 minus y1 over x2 minus x1. Looking at the red one, I'm going up 1 over 5, so the slope is 1 over 5. For the green one, I'm starting from 0, so I'm going up 2, rise is 2, and running is 3, so it's 2 over 3. For the black one, I'm going to go up 5 over 3, so it's 5 over 3. This has a higher slope, the black one, compared to the green one, compared to the red one. And they're all positive, by the way. If it forms an angle, if it goes all the way to the left, forming an angle more than 90, less than 180, the slope is going to end up negative. For the red one, we're going from 5 back, let's say, to 2. So we're going backwards 3 units. That's running negative 3. We're rising 2. That's positive 2. And we prefer to put the minus up front, so it's negative 2/3 simplified. For the green one, I'm going to go from this point to this point. 1, 2, 3, 4 to the left. 2 up. 2 over negative 4 simplifies to negative half. And that's like, if you want to do it as subtraction y2 minus y1 over x2 minus x1 for the red one. The slope-intercept form of an equation is y equals mx plus b. For this example, the y-intercept, where it crosses the y-axis, is at y equals 2. We call it b. That's the y-intercept. The slope, we could read it as rise over run, which is 1/3. So the slope is 1/3, and the y-intercept is 2. So the equation is 1/3 x plus 2. Let's take another example. This graph shows that I'm going left 3, negative 3, and up 2, and the slope is positive 2 over negative 3, simplifies to negative 1/3. Now, for this graph, this point and this point will do the job, but if you pick a different point on the graph, like this point right here, up to this point, you're going to get 1, 2, 3, 4 rising, 1, 2, 3, 4, 5, 6 negative as a run, simplifies to 4 over negative 6, which is negative 2/3. Now, if you don't want to pick this point, you pick this point, which we could clearly see at the level 3. It crosses the grid right there. That's running negative 3 and rising 2. 2 over negative 3 simplifies to negative 2/3. Same answer. One more time, this is another example. You pick any 2 points, and it's going to give you the same ratio of rise over run, same slope. Here's a different example to show you that once you locate the 2 points, this point and this point, which is the same here and here, it doesn't matter which one is your first point, which one is your second point. It doesn't matter if you want to run first or rise first. As long as you keep it clear, rise over run, you should end up the same slope. So if I go up from this point, then left, my rise is positive 4, my running is negative 3, simplifies to negative 4 over 3. On the other hand, if I go down, I'm going to go down 4. So the rise is -4, where here the rise was +4. Running is 3, so it's going to be -4 over +3, which simplifies to -4/3. Same answer. Quick note, slopes of lines will be if the line is going up, forming an angle that is acute, an angle that is more than 0 and less than 90 degrees will give you a positive slope. If the angle with the positive x-axis is more than 90, less than 180, it's going to give you a negative slope. A horizontal line has a 0 slope. A vertical line has undefined slope. If you use y2 over y2 minus y1 over x2 minus x1, I get from these points identifying which one is x1, y1, which one is x2, y2. This is my y2, and this is my y1. 6 minus 3 goes on top. That's 6 minus 3, which is the y2 minus y1, 3. And running will be x2 minus x1. That's my x2. And that's my x1. 7 minus 2 goes at the bottom side, which is 5. So it's 3 over 5. And you could just do the math this way, putting the numbers right here. And this is what I'm showing you. 6 minus 3 over 7 minus 2. 6 minus 3 over 7 minus 2. 3/5. Another example. Going left 5, going up 7. It's going to be positive 7 over -3. -5, I mean. Simplifies to -7 over 5. Graph the line passing through the point 1, -1, whose slope is given to me as 3/4. First, we locate the point 1, -1, which is down here. And we're going to go up and right, following the slope, which is rise 3 and run 4. Rise 3, run 4. Locate this point, mark it, and connect the lines as you could see right here. So you have a point, and the slope tells you where to go to get to the other point. Graphing the line using its slope and y-intercept. Well, this line is given to me as 1/2 x plus 3. So my y-intercept is 3. I'm going to go up 1 over 2. That's my rise and run to reach to another point. I could do the same 1 and run 2, rise 1, run 2 to get to another point, just to double check and connect them. Graph the line y equals -x plus 4 using its slope and y-intercept. Well, here in this case, comparing it to y equals mx plus b, b is 4. b is 4. And the slope is -1. But it doesn't tell me what's my rise and what's my run. It's not a fraction. You could write any number as a fraction. -1, the easiest way, I'll write it -1 over 1. So that's my rise and that's my run. So locate the 4 on the y-axis. That's your y-intercept. Follow the rise over run, or the slope. Rise 1, that means go down 1. Run 1. Locate this point, mark it, connect the lines, and you're done. Some applications. In math, we use x and y. In real life, it's not just x and y. It's something else. It's time and money, miles, and so on. This equation F equals 9 over 5c plus 32 is used to convert temperatures. C is Celsius scale and F is Fahrenheit scale. So in this problem, this is my x, this is my y. That's my Celsius instead of x. and that's my Fahrenheit instead of Y. What does the slope 9 over 5 and what does the Y-intercept 32 means in this problem? Because in math, when you speak rise and run and X and Y-intercept, students sometimes don't get the concept, like, why do you have this? What's the benefit of it? Here's an example. So here it's above 30 if you pay enough attention to it. And the equation says it. The Y-intercept is 32, so it crosses the Y-axis at 32. What does it mean? It means when C is 0, you're not going right or left. Your Fahrenheit is 32. It means that the F-intercept, instead of calling the Y-intercept, means that when the temperature is 0 Celsius, it's 32 Fahrenheit. In a different way, 0 Celsius corresponds to 32 Fahrenheit. That's what we have. Now the slope is saying 9 over 5, but 9 corresponds to my Y, or rise, and 5 corresponds to my X, which is C. So I'm gonna rise 9 and I'm gonna run 5. Differently, I could run 5 and rise 9. That means every time I increase the Celsius by 5 degrees, I'm gonna have to raise or increase the Fahrenheit degrees by 9. Every time the Celsius increases by 5, the Fahrenheit will be increasing by 9. Let's read this. It means that when the temperature is, down here. It means that the temperature F increases 9 degrees when the temperature C increases 5 degrees. Let's take another example. Sam drives a delivery van. The equation C equals 0.5 M plus 60 models the relation between his weekly cost C in dollars and the number of miles M that he drives. So my X now is miles, number of miles, and my Y is cost in dollars. If the Y-intercept is 60, what does it mean? This right here, the C-intercept or the Y-intercept, it means when the number of miles driven is 0, the weekly cost is $60. Meaning, you rent the van for a week, and on the contract they say, we're going to charge you $60. On top of that, we're going to charge you on how many miles you're going to drive. So that's kind of like the $60 is your initial cost, your starting cost. Means even if you don't drive the truck, you have to pay $60. So the number of miles, when it's 0, you are paying $60. That's your Y-intercept. That's the meaning of the Y-intercept. Without driving the car yet, without driving any miles, you are supposed to take care of $60 as a weekly cost or rent. What does the 0.5, which is a slope, means? It's written as a decimal 0.5. What does it mean? Well, 0.5 could be written as with units, a $sign 0.50 over 1 mile, which is 0.5 over 1, which is a fraction as 1/2. So it's a $0.50 per mile. Let's read this. The slope 0.5 means that the weekly cost C increases by 50 cents when the number of miles is driven is 1 or increases by 1. Or seeing it as a fraction, you're gonna rise 1 every 2, or every 2 miles you're gonna increase by $1. So it's gonna cost you $1 for every 2 miles you drive, or it's gonna cost you 50 cents for every mile you drive. So that's the concept of slope in real life and the Y-intercept. Okay, let's see some more examples. These two lines are parallel. They're going to have the same slope. You could see the ID of the slope and the same angle. Rise over run, rise over run, 2/5, 2/5. In case if you have perpendicular lines, the slopes are not the same. We say that they are opposite with the negative sign, reciprocal. Or if you multiply both sides by m1, I get m1 times m2 equals -1, where m1 is the slope of the first line or one of the lines, and m2 is the slope of the second line. Now this right here has its own slope in green, rising 1 and running 4. The slope is 1/4. I called it m2 as my second line. Here's my first line. Using red, I'm running 1 and I'm rising in a negative direction 4 units. As you can see, 1, 2, 3, 4. So it's -4 over 1, which is -4. But look at these two slopes. We have 1/4 and we have -4. They are opposite reciprocals. And if you multiply them, you should get -1. Notice that how the slope looks like in our graph. Your running is your rising, how much you run, how much you rise. How much you here run is how much you rise here. And they're opposite with numbers. Use slopes and y-intercepts to determine if the lines are parallel. Here's some examples. 3x minus 2y equals 6 and y equals 3 over 2x plus 1. Well, this one is clearly, we have the slope which is 3 over 2. This one we don't know, so let's work on this one. I'm going to subtract 3x from both sides. I'm solving for y to make it look like this. After that, I'm going to divide by -2. Of course, here you're going to divide both terms by -2. Simplify, and I get 3 over 2x minus 3. Same slope like the other line. So y1 is 3 over 2x minus 3, which is this one, and this is y2. Same slope, different y-intercept. That means they cross the y-axis at different locations, but they have the same ratio of rise over run, so they are parallel lines. Another example. Use slopes and y-intercepts to determine if the lines are parallel. This has a slope of 2. This one is not clear for me at this moment, so we're going to do the math. We're going to add 6x to both sides to leave y alone. Then we're going to divide by 3. Of course, you divide by 3 both terms. Simplify, and I get the slope of 2. And the slope was 2 for the other one. So both have the same slope. But this problem is a little bit different. Same slope and same y-intercept. So if you graph this line and you try to graph this line, it's going to be on top of it. So we don't have two lines. We have one line. The same slope and same y-intercept means same line. So the lines are coincident. That's what we call them. And they are not parallel. They are the same line. Because parallel lines means they don't intersect. But these ones, they intersect all the way because it's the same line. So we call them not parallel. Just be careful. Use slopes to determine if the lines are perpendicular this time. Well, the slope here is -5 and this one is not clear. So let's work on this one. Leave y alone. Subtract x. Divide by -5. Simplify. I get the slope 1/5, and the first one was giving me -5. But that is what we want. Opposite reciprocals. You could double check by multiplying them to get -1. So they are perpendicular. Let's take another example. 7x plus 2y equals 3 and 2x plus 7y equals 5. Now they're both standard form. I want to change each one to y equals mx plus b slope-intercept form to compare the slopes. Subtract 7x from both sides, divide by 2, simplify, I get negative 7 over 2. Subtract 2x from both sides, then divide by 7, simplify, I get negative 2/7. They're almost perpendicular or parallel, but they're not. First of all, they're both negative, so the word opposite is not there. So they're not perpendicular. Besides, if this is negative 7 over 2 and this is negative 7 over 2, we'll call it parallel. So the slopes are reciprocals of each other, but they have the same sign, so they're not opposite. Since they are not negative reciprocals or opposite reciprocals, they are not perpendicular. Of course, they don't have the same value, exact value, so they are not parallel. With that, I'm done with this section. I'm doing my best not to make it over 30 minutes, and it looks like I made it about maybe 26 minutes. Okay, thank you for watching. I'll see you in the next one. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.